Cool. So hi everyone, my name is GregStanley, and this is my Geographic Information Systems Technology Master's Project about hotspot analysis and exploratory regression on harmful algal blooms in Florida. So to start off, I'll go over the basics of a harmful algal bloom, also known as an HAB. And it's essentially a type of phytoplankton that carries a neurotoxin that has adverse health and hazardous effects if you come in contact with it. So the one found in the Gulf of Mexico, the most common one is the Karenia brevis, which is responsible for creating red tides. And these occur naturally 10 to 50 miles offshore, but grow in concentration and size and length and time increasing as they move closer to shores. And they become a threat at 20,000 cells per liter or larger. And the way they affect marine life is that they attack the central nervous system, eventually killing off any animals or plants that come in contact with it. And with humans, if they're around the shore, they can breathe in the toxins, or if they ingest any seafood, then it can cause respiratory illnesses and sometimes death as well. So with manatees, there's a direct effect coming in contact, but also indirectly. If their food source, seagrasses, are killed off, then they starve to death. And also, seagrasses, ironically, are responsible for filtering any nutrients or pollution that would otherwise help feed the HABs. So some conditions of HABs include temperature. They can survive in waters 50 to 90 degrees Fahrenheit, ideally 72 to 82 degrees. Salinity and chlorophyll, they tend to favor higher concentrations for HABs to grow. Currents and wind patterns, these help move the HABs since they can't move on their own. And as they move them closer to shore, they have access to nutrients, specifically nitrogen and phosphorus. And there's numerous sources where we can obtain nitrogen and phosphorus, including dead sea life. As they decay, they they release nitrogen and phosphorus. Upwelling, so nutrient-rich waters coming from the ocean bottom. Atmosphere, including nitrogen, fixated nitrogen. Runoff from different facilities in agriculture, as well as other algal blooms. So non-threatening algal blooms have nitrogen and phosphorus that an HAB can eat or consume and then absorb their nutrients. The objectives of this project first use density analysis, specifically hotspots, to determine any type of clustering or patterns for the harmful algal blooms, as well as 5 other data sets that will be used as candidate variables to help explain the occurrence or relationship to the harmful algal blooms. And I did this for the years 2015 to 2020, so 6 years worth of data. And the second part, the exploratory regression, helps determine there's a correlation between HABs and 5 other factors. So HAB will be our dependent variable. I use 3 toxic release inventory categories as independent variables, as well as salinity and chlorophyll. And I'll go over those data sets right now to see the distribution across Florida using these maps that I made. So here we have the harmful algal bloom events for 2015 to 2020, measured cells per liter. And you can see how frequent and how often they happen, to the point where they're measured in the millions. So this is taking the summation of each location. So that's why we're able to see how frequent and how high concentrations they are for even just 1 year. So we can already see some clustering happening without even running any analysis around Tampa Bay and Cape Coral, as well as the Panhandle area. Here are the 3 TRI categories. We have chemicals released as offsite wastewater disposal, chemicals released to air, water, and land at the facility, and chemicals released as surface water discharges for the years 2015 to 2020, and they're measured in pounds. You could see the differences for each category and how much they were released and where they're released. And this is assuming that each of these categories have the nitrogen and phosphorus needed for the harmful algal bloom to thrive. Finally, we have our concentration of salinity as well as chlorophyll taken from the Gulf of Mexico Coastal Ocean Observing Systems website. And this is assuming that only chlorophyll takes place in Cape Coral and only salinity takes place in the southern tip and a little bit in the panhandle. But we know that salinity is everywhere in the ocean, as well as chlorophyll, anywhere there's plant life. So my methods, I'll go over the two methods that I use for this project in more detail. First would be hotspot analysis. This is used in ArcPro, and this tests all 6 data sets for complete spatial randomness as our null hypothesis, or if there's any type of spatial clustering or patterns taking place. And the way you determine that is you can use 3 different levels of confidence levels over here. And for each one, we're saying how low the probability is of the null hypothesis to take place. And with that, there's an associated standard deviation, so the tail ends of the bell curve. So as the confidence level increases, the probability of CSR taking place decreases. So with hotspots, you'll see high values of clustering and the points getting redder with each confidence level increasing. And with cold spots, these are still values or points, data points of clustering, but there's lower values. And you'll see those points get bluer as the confidence levels increase. For exploratory regression, the second method, this tests the HAB as the dependent variable against the other 5 data sets as the independent variables for spatial correlations. And this chooses the top 3 ordinary least squares or OLS regression models for each of the 5 summaries. There's 5 summaries because we have 5 independent variables. And there's 6 criteria for a model to pass with OLS. The first one being adjusted R squared. This tells you whether the variables are good or bad at explaining the dependent variable with a range of 0 to 1, 1 being the better value. Ike information criterion, or AIC, you want overall the lowest value, because that means that you need the least amount of variables needed to explain each model. Yark-Bera, that tells whether the residuals are the predicted versus the observed value. They tell whether this tells whether they are normally distributed or are biased. And again, that uses a range of 0 to 1, 1 being the better value. Poinker-Bruch-Pagan, this tests for homoscedasticity, meaning that seeing if the residual errors are equally scattered or not. And generally, you want a p-value of 0.05 or greater. If it's lower than that, then you have heteroscedasticity, meaning there's variance amongst the independent variable increasing. Variance inflation factor, this tests for multicollinearity, meaning how independent the variables are from each other. And you generally want a 7.5 value or lower. And finally, spatial autocorrelation, this checks for spatial clustering of the residuals. And anything above 0.1 means that you aren't missing any key variables to your models, that you don't need to add or modify any of the independent variables. And here's a quick model builder that I used to run the exploratory regression. So we have a fishnet that I created of polygons across the ocean and as well as Florida, since there's no county lines or anything to summarize the values within them. And with that, I used the mean summation or summarization for each data set. So here are the 6 data sets, basically building a big attribute table for all 6 data sets and then running exploratory regression. So for my results, I'll first go over hotspot analysis, showing HAB hotspot analysis on the left with each variable on the right. So here we have our hotspot analysis for HABs. And as I mentioned before, each point for cold or hot will get more blue or redder with each confidence level increasing. So here we can see a big confidence level hotspot for Tampa Bay and Cape Coral area. So high value hotspots, and then lower value cold spots for the Pensacola and Panhandle area, as well as the southern tip. And here is our first TRI data set with no significant cold or hot spot taking place. And I think that was probably due to very sparse data for that particular TRI category. Here's our second TRI category. We can see we have a strong hot spot for Pensacola. And our third TRI category, kind of a weak cold spot just east of Tampa Bay. For salinity, we have two 95% confidence cold spots in the middle of the Panhandle, as well as Palm Coast, Jacksonville area. And then finally, a pretty strong cold spot, so low value, but still strong clustering for chlorophyll. For exploratory regression, I'll go over the 6 criteria for generally all the models and see if they passed or not. So for adjusted R squared, they all range from 0 to 0.01, which is too low. Remember me saying you want a value closer to 1, meaning you do have good explanatory variables to explain the occurrence of HABs. AIC, these values range from 24,096 to 24,104. So not much significant range amongst each other, but you still want to use the lowest value, meaning that's the least amount of variables needed to explain the HAB. Yark-Bera, all models were 0, which indicates residuals were biased. For Wenker-Bruch-Pagan, we had a p-value range of 0.61 to 1, meaning that there's homoscedasticity present amongst the residuals, so not much variance as the independent variables increase. VIF all had a value range of 1 to 107, which are passable values because we want the value to be 7.5 or lower. And then finally, spatial autocorrelation, all models resulted in 0, which means I'm missing key variables. So therefore, unfortunately, none of my models pass for all 5 summaries. But if I were to choose the best one, it would be chlorophyll in summary 1, based on the 6 criteria values. So here we have the top 3 OLS models for each summary. And here are the values for chlorophyll. 0.01, 2496, 0 for JB, Wenker-Bruch-Pagan 0.61, a VIF of 1, and a spatial autocorrelation of 0. So in summary, HABs for hotspot analysis had strong high-value hotspots in Tampa Bay and Cape Coral, low-value cold spots in Panhandle and southern tip of Florida. Salinity, very strong low-value cold spots in the Panhandle and Palm Coast. Chlorophyll had a very strong low-value cold spot area in Cape Coral. Chemicals released to air, water, land, and at facility, that's one of our TRI categories, had very strong high-value hotspots in Pensacola. Chemicals released at surface water discharges, we had weak cold spots east of Tampa Bay. For exploratory regression, no models passed, but chlorophyll still showed the strongest possible spatial correlation to HABs. Therefore, I will need other variables to improve the adjusted R squared, as well as the other criteria will hopefully improve when I find better variables. And the way to do this, I could probably investigate using water temperature data sets, currents, other natural sources of nitrogen and phosphorus, and possibly other TRI categories that I may have overlooked. And also, there weren't enough chemicals released as offsite wastewater disposal, salinity, and chlorophyll locations to sample the data from. So remember, the chlorophyll only showed, I think, in Cape Coral area, and salinity only showed in the southern tip of Florida and a little bit in the Panhandle. But overall, this is still useful information to educate the general public, work with the government, maybe other organizations to warn the hazardous effects of HABs and hopefully find ways to maybe mitigate them. Here are my references. I expect you all to memorize them in the next 10 seconds. And that's my project. Thank you for listening.